different gradients that we've got here. Who should I ask for the first one? Nabil, what did you get for the gradient? Can you just show me what your first line of working out was for M?
10 minus 4.
Yep. So that's the change in Y
3 minus 1.
over 3 minus 1, which is the change in X, doing it in the same order. So you get 6 over 2 or 3, yeah? Just a quick side note, if you did do it the other way around, if you did the 4 minus 10, and if you did the 1 minus 3, you would get minus 6 over minus 2, but a negative divided by a negative is a positive, so you would still get the same value of the gradient. It doesn't matter if you do this one minus this one or this one minus this one, you still will always get the same values, okay? How about Awa, for the second one, what did you get for the value of the gradient here? If you could just talk me through what your M looked like. Yep. So that's minus 6 over 3, which is minus 2. So we've got a negative gradient for that one. And then for this one that we've got here, Taylor, what did you get for the third one here? If you can just talk me through that, please. So you've got 8 over minus 3. Faisal, I saw that you did something extra. When you had 8 over minus 3, you wrote that in a slightly different way. You wrote minus 8 over 3. Sometimes you might see that written as minus and then 8 over 3. So the negative, usually, we would tend to put it next to the fraction or on the numerator. We would not leave a negative in the denominator when we're describing any kind of thing, really. This is not the ideal way. We would much prefer this one or this one that we've got here, okay? Last thing that we talked about, well, we started talking about as you were practicing on these, is we were talking about these 3 different points. We had A, B, and C, and if they all lie on a straight line, Ishraq, I heard you describing this to, I think it was Zishan. What was your theory of your idea of this?
From point A, line A, B, and AC should have equal gradient.
A, B, and AC should have equal gradient. Is there another one, a pair that should have equal gradient?
And BC.
Yeah, AB, BC, and AC should have equal gradient. If you just think about 3 points, A, B, and C, if they are on the same straight line, then the steepness of that line, the steepness of that line, and the steepness of the overall line should be the same. If it wasn't, you would have A, B, C. Here's them not on a straight line. Clearly, that gradient, and that gradient are all different to each other. So, Ishraq, you might as well then tell me, what did you get as which gradients did you do? C and A, and then B and A?
Yeah, so for A and C, I got a half. So I did A.
So I'm just going to, before you do that, if you're doing the gradient of A and C, sometimes you write the M and then a little A and C to say that we're doing the gradient of the line segment AC. What did you get for that then?
The change in Y 4 and the change in X 8. So 1 over 2.
So yeah, you've got your 8 minus 4 and your 11 minus 3, which is 4 over 8, which is a half. And then which other gradient did you look at?
A and B.
And the gradient of AB, and what does that give you?
5 minus 4 over 3. 5 minus 3 is 1 over 2.
Which is 1 over 2. So here we could say, as gradients, MAC equals MAB, which is equal to a half. A, B, and C, there's going to be a new word here, are collinear. So you should be able to tell me now what the word collinear means. Yeah, it means they lie on the same line. If we say that something is collinear, it means it lies on the same line. You may come across that word now. If I say to you in this topic, possibly in a vectors topic that we're going to be doing very soon, if I ask you to see if if 3 points are collinear, it means are they in the same line? And what it actually means is, do they have the same gradient? I would be very impressed if any of you can remember this when we do the vectors topic, that you can tell me collinear will mean they have the same gradient. I'd be very impressed if anybody remembers that. Okay, so keeping going at the very high speed that we're doing here, we'll do one quick example on where the gradient is not, where you don't have the coordinates. This time you're told what the gradient is. So it says the line joining 2 minus 5 to 4a has gradient minus 1. Work out the value of a. So we just set it up in the same way as we have done before. We normally have that m equals y2 minus y1 over x2 minus x1. So we're just going to do the same thing. The gradient is minus 1, and the change in y is a minus minus 5. Be really careful. We're subtracting negative 5, and we're dividing by 4 minus 2. So we end up with minus 1 equals a plus 5 over 2, multiplying up by 2, minus 2 equals a plus 5, and subtracting 5, a is equal to minus 7. You're going to do quite a few questions like that for me in a moment. So just being aware of, you might get an unknown somewhere else. Okay, you might get an unknown somewhere else. I'll just quickly recap what we did. We said the gradient was minus 1, and we found the gradient as normal. We then simplified and solved the equation to come up with a is minus 7. Okay. This next slide is just for us to discuss some things from GCSE. So here I've said one form we can put a straight line equation in is y equals mx plus c. This is a very useful form because very quickly we can find out what the gradient is, what the value of the gradient, and very quickly we can find the value of the y-intercept. However, you must be very careful because the left-hand side must be y equals to be able to find out what the value of m and the value of c is. Again, this is probably something that's obvious to the vast majority of you, but if you had an equation like, I don't know, 3y plus 2x equals 4, the gradient is not 2, and the y-intercept is not 4. It's not just the numbers that you have there. It must be rewritten first of all so that you have it rearranged with y equals. Then you can work out what m and c are. Okay, pretty obvious, but just need to make sure that everybody is completely on the same page before we move on from here, okay? So we'll have a quick look at a few examples that are like that, and then it's time for some practice for a little part of the lesson. I wonder if we can do most of this really quickly. I think this is probably only going to take a lesson and a half rather than 2.5 lessons. Can I go on to this next slide? Yep. So here, I want to determine the gradient, the value of m, and the y-intercept, the value of c, of the line with this equation that we have here. This is kind of a more familiar version of equations that you're going to see in A-level. And I've put a few different things for the steps here. Make y the subject so that we have the form y equals mx plus c. We know that's the form that's going to help us find out what m and c are. And put the y on the side where it's positive. So let's start off with that. We have 4x minus 3y plus 5 equals 0. So it's better, which terms should we be moving, or which term should we move? The y, because we want this to become positive. So we get 4x plus 5 equals 3y. The second step that I've put here is that we're going to divide each term by 3 because of the 3 that we have here. But we don't write y equals 4x plus 5 over 3, otherwise it's not in that correct form. So although we may be tempted to do this, it's not the best way of doing it. The better way of doing it is to divide each term individually by 3. 4x divided by 3 is 4 over 3x. Some of you may not be aware of 4 over 3x is the same thing as 4x over 3. These are completely the same thing as each other. So if you ever want to rewrite it to make it look better, obviously those two things are the same as each other. So this is the same thing. And then we have plus 5 over 3. The last bit that I've written here, because this is algebra, you should use improper fractions and not mixed numbers or recurring decimals. I'd much prefer 4/3 than I do 1 1/3 or 1.33333 or 1.3 recurring. And I obviously prefer 5/3 as well. Everything that we're doing now, unless it's a modelling question, like the ones we did with the throwing the rugby ball, everything should be in fractions and top-heavy fractions. So my value of the gradient is 4/3, and my y-intercept is 5/3. Okay, nothing super exciting there, unfortunately. Mr. Udin got the good lessons at this point, but I'll get some of them later. Okay, one last thing before I can send you off to do a variety of practice is here. At GCSE, y equals mx plus c was the main form that you would express a straight line equation, sometimes known as the slope-intercept form. Why do you think it's called the slope-intercept form, y equals mx plus c? Why could this thing here be called the slope-intercept form? Do you know what the word slope means? Yeah, it's like you're showing, lots of you are doing like tilted arms for this. It's just another word for gradient. So the slope-intercept form is because the slope-intercept form. But another common form is ax plus by plus c equals 0, where a, b, and c are integers. And this is known as the standard form. Okay, this is a standardized form of writing equations. So we're just going to have a quick go at doing this one here. You're going to do this one here, and then it's finally over to you to do some practice. So at the moment, we have got it in its slope-intercept form. I've got clearly the gradient is 1/3, and the y-intercept is -2/3. But I want to be able to get it in a form where all of the coefficients are integers, whole numbers, okay? So what do you want me to do? I want to multiply every single term by 3. So I get 3y equals x minus 2. And it all wants to be on one side of the equation. So I could say x minus 3y minus 2 equals 0. Or how else could I have written it instead? Can anybody see how else I could have written it instead of this one? Yeah, I could have, well, I did minus the y, actually, I minus the y there. I didn't need to do, what do you mean about the dividing by 3? I multiplied this by 3, I multiplied this by 3, and I multiplied this by 3. No, because of what it says here, where a, b, and c are integers. So everything needs to be an integer for it to be in that standard form. A, b, and c have to be integers for it to be in standard form. Sorry, what was the other way I could have written this? Good, I could have written it on the other side. So it was minus x plus 3y plus 2 equals 0. Ishraq, any opinions of which you think are better between these and why you think they might be better? Yeah. So this one is the one you think better? Yeah, I agree. I think this one's better because we normally in maths like to start the sentences with a positive, whereas this one here is starting with a negative. So all you need to very quickly for me do is this equation that we have down here. So change that into standard form, and whilst you do that, I'll do it so it's on the video, and then we'll finish up.